Today's Cloudcast is sponsored by Datadog, a modern, full-stack monitoring platform for cloud infrastructure, applications, and log metrics all in one place. Use Datadog's customizable dashboards to monitor, correlate, visualize, and alert on data from devices and cloud backends to have full visibility into performance. Datadog breaks down the silos within an organization's teams and removes blind spots that could cause potential downtime. With over 350 integrations, Datadog makes it easy for teams to collaborate together and monitor every layer of their stack within a single platform. So try Datadog for yourself with a free 14-day trial, and you'll receive a complimentary t-shirt. Just go to datadog.com/cloudcast. That's datadog.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everyone is doing well. Here in the United States, we're just coming back from a bit of a break and kind of in the middle of summer and trying to both stay safe and stay cool all at the same time. We're going to jump right into Cloud News of the Week. We have a number of acquisition stories this week, as well as a little bit of serverless news as well. For our first story, we have an acquisition recently by ServiceNow. ServiceNow picked up Swiggle. Now, I wasn't familiar with them, but went and did some digging on them. A smaller company, about 15 employees or so, and based out of Belgium. But their niche was configuration management and more specifically DevOps related. And so ServiceNow was a good pickup for them. Add this into the portfolio. There is also a little bit of, just like everything else, it seems like a little bit of machine learning thrown into this as well. Should be a good acquisition for them and looking forward to seeing what comes out of that. And moving on to our second story, Salesforce. Salesforce has a serverless announcement. Salesforce has released Salesforce Functions, which, of course, is exactly what it sounds like. It is serverless functions running on top of Salesforce and able to utilize the infrastructure and the data within Salesforce. So if you are interested in that and of building apps on the Salesforce platforms, then now you have a new tool in the tool bag going forward. They also, in addition to that, introduced Code Builder, which is a web-based IDE. So really building out the tool set here to further enhance all of the offerings Salesforce has had over the years. Our third story is actually not an acquisition. This is about AWS, and AWS did an announcement a couple weeks ago now, but we didn't cover it because of the holiday break. They announced Honeycode, a fully managed service that is a low-code, no-code application builder. And of course, we've seen here on the show a decent increase in this space in the last couple of years, and a lot of interest in this, and also some of the interest probably stems from just, quite frankly, at times maybe a shortage of developers and how can folks just kick the tires and get going a lot faster. And so, you're seeing this AWS mantra come out again of this constant reduction of friction and how can they get people into the ecosystem and lower the bar to entry as quickly as possible. So looking forward to getting more information on that here in the near future. And finally, closing out, Catchpoint. Catchpoint did an SRE report. Now, what's interesting about this is the SRE report, they actually collected a bunch of data back in February. And of course, with coronavirus and the global pandemic, they decided to then collect another set of data in May of this year. So you get a before and after snapshot of this, of how is working remotely affecting SREs globally. Really, really interesting data, and I really like their use of using both the before and after data as well. So if that's of interest to you, this and of course all the other stories, the links are in the show notes. We have a really interesting interview coming up today, and it's the last in an artificial intelligence series I've been recording here over the last couple of weeks. We have MoveWorks coming up to talk about AI for IT support.
Today's show is sponsored by StrongDM. Are you transitioning your team to work from home? Are you managing a gazillion SSH keys, database passwords, and Kubernetes certs? Well, meet StrongDM. Manage and audit access to servers, databases, and Kubernetes clusters no matter where your employees are. With StrongDM, you can easily extend your identity provider to manage infrastructure access, automate onboarding and offboarding, and move people within roles. You can even grant temporary access that automatically expires to on-call teams. Your admins will get full auditability into anything anybody does, when they connect, what queries they run, and what commands are typed. This means full visibility into everything. For SSH, RDP, and Kubernetes, this means video replays. For databases, it's a single unified query log across all database management systems. StrongDM is used by companies like Hearst, Peloton, Betterment, Greenhouse, and SoFi to manage access. It's more control and less hassle. That's StrongDM. Manage and audit remote access to infrastructure. Start your free 14-day trial today at strongdm.com/cloudcast.
And we're back. This week we have, again, a little bit in the AI and ML space, an area we've been exploring a little bit in recent weeks. And we want to get into natural language understanding, or NLU in particular. And for that, we've got Vaibhav Navargi, CTO and founder at Moveworks. Vaibhav, welcome to the show. And tell everyone a little bit about yourself and what got you started in this AI space.
It's great to be here. Thank you for having me. So I am one of the founders and CTO at Moveworks. A little bit about Moveworks itself. So we are about 4 years old as a company based in Mountain View, California. And we have been incredibly fortunate to have partnered with some of the top VCs in the world, like Kleiner Perkins, Iconic, Lightspeed, Bain, and have raised over $108 million so far. What we do at Moveworks and what we have built is a product that lets employees inside large companies, companies like Western Digital and Broadcom and Nutanix and dozens of others, household names all over the world, have their employees use natural language to communicate with Moveworks and have Moveworks autonomously and instantaneously resolve IT tickets. If you've been inside a big company, at least when we used to go to the office in the good old days, people had a few options, right? They could go up to an IT help desk kiosk, they could call a number, they could send an email, or they could go to a portal. And that experience usually is pretty slow. From our experience, having analyzed over 75 million IT tickets now, we have seen that average resolution times can be up to 3 days. And that, if you have 1 billion knowledge workers worldwide, is just a huge drag on productivity. So when my co-founders and I got together 4 years ago, we had this vision of using the latest in artificial intelligence and natural language understanding to understand not just syntactical elements of language, but the semantics of IT-specific enterprise language, and then connect it to either automation that IT teams have been building over the years, or have automation that we build to take these tickets all the way through completion in a minute or less compared to 3 days. So that's what we've been focused on. We have hundreds of thousands of employees across our customer base use Moveworks every week now. And on any given week, we resolve between 30 to 40% of all employee-reported tickets inside these companies. In terms of my journey itself, it's been somewhat unconventional. I got my start working on the very low levels of the system stack. So around 15, 16 years ago back in India, I was hacking on the Linux kernel and getting it to scale on NUMA processors and SGI supercomputers, and using scientific workloads and genomic sequencing and other kinds of really complex and heavy processing to run efficiently on these computers. I worked on storage systems and InfiniBand and gigabit Ethernet drivers and so on. That led me to Stanford, where I got my first taste at machine learning, which was actually the classical machine learning, because deep learning renaissance hadn't really come back then. But it built in me an appreciation of using data, training models to generalize these really complex algorithms based on what you have seen to what you haven't seen. I also specialized in distributed systems and databases, which led me to join Astrodata, a startup which was formed on Stanford campus, and I joined them as an early employee. And currently, if you have to store large amounts of data, all you have to do is go to AWS or go to Google, and you can sign up for Redshift or you can sign up for BigQuery, and you're done in seconds. But 15 years ago, it was pretty hard, and we had to solve a bunch of gnarly problems in getting databases to scale, to ingest data quickly, to organize it, and get our customers to run complex workloads, things like fraud detection and customer optimization. And we use MapReduce and columnar storage. And that formative experience helped me in starting my first company, which was Clear Story Data, in the data visualization and analytics space, which focused also on machine learning for large enterprises and helping line of business users introspect their data and derive insights from it. So my journey has been sort of from the data infrastructure, big data side to understand and appreciate what data can give you, which led my co-founders and I to come together and start MoveWorks.
Nice. And so I have a couple different paths I'm going to go in from there, but let's continue along the AI ML path and explore this concept of natural learning understanding, or NLU, a little bit. And as I understand it, and you tell me if that is correct, but it really is, exactly what it says, which is instead of, I'll use the term talking or interacting with the AI ML in maybe its language, if you will, it's more natural language. And it is more in the lines of like chatbots or some of these other things. And I almost hesitate to use the term, but it's almost like a, dumbing down of the interface, if you will, into something that everyone can use, because AI ML is a lot of times seen as a, not quite as approachable concept in, the infrastructure world as a lot of the others. So tell everyone a little bit about NLU.
Yeah, that's a great question. And it is useful to think about this as an umbrella of topics. So natural language understanding is definitely a part of the larger AI and machine learning umbrella, and is related but different compared to natural language processing, which talks about getting computers to parse and work with language, but it's more statistical in nature. And it has natural language processing has more to deal with parts of speech and understanding relatively simpler structures around information retrieval. So understanding keywords and entities and things like that. Where natural language understanding comes in is it's more complicated than that. And that has to deal with computers and machines understanding, comprehending language. And that sort of is illustrated by an example. So let's say you're building like a simple chatbot, given that's a very common manifestation that people think about. Natural language processing has to deal with an utterance like, I need some pizza. And you have a bot that understands that. What does pizza mean and what does I need mean? It's relatively simple. But natural language understanding has to deal with a language like, I am hungry, and making the connection that, okay, you need food, you need some pizza, which is a slightly different conversation to have. And similarly, in our world, given we deal with IT tickets, if you see something like, my window is frozen. So comprehending that means that, okay, most likely you're running an application on your desktop. You need to figure out which application that is and why that may be causing a problem, and helping an employee troubleshoot that problem. Or if somebody says, sorry, I dropped my laptop, I don't know what to do. You can understand that it has laptop and who the person is, and that's where processing stops. But then understanding means, okay, that means your productivity is going to get impaired. So maybe our bot says, here's a laptop form that you can fill out to get a new laptop. So in that way, NLU is a subset of NLP, but it's a much harder problem. And it has to deal with really the versatility, ambiguity of language. There's a lot of assumptions around context and metadata when these models get built and trained. And it comes up in domains like question answering, in language translation, in things like text summarization or common sense reasoning. This domain has seen a huge improvement in the last couple of years, thanks in a large part due to innovations in deep learning and things like word embeddings, which assign mathematical weights to words, and sentence embeddings and topic embeddings and things like that, as well as large companies like Google, Microsoft, Facebook, which have the infrastructure and the massive corpora of data to train things like BERT and GPT-2 and XLNet. And these large models give a baseline for companies like MoveWorks and others to train more sophisticated natural language understanding models towards resolving employee tickets.
And it's funny. So I'm not even sure if I've even ever said this on the podcast, because it goes back that far. But when I was in college, I actually was a co-op for IBM. I would alternate computer science classes and working at IBM. And when I worked at IBM, I was actually doing tech support.
Interesting.
And so, I mean, I'm not going to date myself on what years I was actually doing this, but let's just say it was a long time ago. And it was funny because, thinking back, you could, probably half the tickets that, if they called, they were unhappy. And then if they did, it was like, well, the computer's broken.
Okay. Well, what does that mean? Tell me what tell me what you mean when you say it's broken, right? Like are
That's
you
right.
getting an error message? Is it not turned on? And you would have to, in your head, mentally go through all of these decision trees and have to interpret a simple statement of my computer's broken, and turn it into something else. And, and I kind of unsolicited plug as well. Yeah. In my day job, I am a customer of MoveWorks, and I've actually, used it quite a number of times through a Slack interface. And it's really, really cool because it is, to your point, it is able to kind of do a certain amount of interpretation. And so is that, probably the primary use case? Is it like the low-hanging fruit, in trying to integrate into Slack and Teams, or is it trying to, go even further and kind of go higher and higher up the stack? Like, tell me a little bit about the goals that it's trying to achieve.
That's a great question. And I especially appreciate the context that you shared around IBM and that tech support thing, because it resonates very deeply with me and with us. And the way that you phrased it is exactly how employees express IT tickets. They use symptomatic language. They say, my computer is broken, or they say, my VPN connection is dropping, or they say something like, this application is crashing. But the underlying root cause for some of these problems could be one of like dozens of different root causes. And that's where you need agents, you need human understanding, you need comprehension to say, okay, this is where you start. Now, what are the other surrounding contextual elements to this problem? And that's indeed where MoveWorks comes in. Now, beyond a certain point, you do need human understanding. If someone says, I'm seeing this weird packet loss in my connection to this data center, that does require an expert who understands what's going on with the network. Or if someone says, my Cisco VPN connection is crashing, here's a log file. Being able to take that and go to the level 2, level 3 side of things is where you still need agents to come in. And that's where MoveWorks happily delegates to agents with additional context about who the user is, what they're saying, what all they have tried, whether a knowledge article helped them, whether some remediation steps help them or not. So that's definitely a case where we see a manifestation with tools like Slack and tools like Teams, given how ubiquitous they are in large enterprises now. And so it makes it so easy for an employee to just type out that message versus going to a portal, logging in, filling out a form, or waiting on call. And we know how overwhelmed IT teams worldwide are. So that's where this gives them a sideband where they can quickly ask this question, get some help, and move on. That's ultimately the goal of MoveWorks.
Nice. And we have been talking a lot, kind of another theme on the show has been this migration to SaaS-based products, right? Mm-hmm. And so what is the model here? Is there a, kind of a central AI that's cloud hosted? Is this private in-house? Do you have the concept of like a template AI and you make copies of that and each customer gets their own AI? Like, tell us a little bit about the under the covers model of all of this.
Yeah, that's a really good question, and we can talk about this for a long time. So I'm going to try and keep this somewhat brief because there are various layers here, right? You're talking about security and performance and compliance and data tenancy, privacy. A lot of concerns going to an architecture like this, but ultimately, what it boils down to is some of the models we train are large global models, but there is no sort of one model to rule them all, right? That's a myth. You do have specialized models and specialized ensembles of models where models work together and act as a pipeline, one model feeding to the other. So in MoveWorks, we have hundreds and thousands of models running in production. And engineers on my team, they train even more models than that. Not all of them make it because their performance may not be there, their accuracy and correctness may not be there. And given we expect employees to get high satisfaction and resolution of these tickets, we only have the models that deliver on expectations of performance, on correctness, and metrics like precision and recall get promoted to production. So with that in that framing, a multi-tenant architecture makes the most sense for a system like MoveWorks. And the models we also train, especially the large ones, they are most efficient to train on GPUs. And for that reason, we have also this private infrastructure where we train these models. And these models, some of them can be trained in minutes and hours, others can take days to train. But whenever they are ready, we have a process where we can promote these models live to production. And we do routinely dozens of model promotions every week. And our customers benefit from that. They don't have to worry about using a toolkit or using some off-the-shelf open source machine learning framework to use their data and then train with it. Because then there's expectation that they are experts in machine learning and they have these engineers who can handle that. And we know that this is still an area which is as much a science as it's an art, as you also mentioned. So that's where we have the expertise and we can give them a service. And our goals and their expectations are in clear alignment. We want our models to perform and we want more tickets to be resolved. And that's what customers want as well. So which is where the multi-tenancy it plays a part. But then we also invest a lot in security, in privacy, in compliance. We are ISO 27001 certified. We are working on SOC 2 Type 2 compliance right now. And we have financial institutions, we have security companies, large tech companies as customers on the platform.
So the idea of training it, so let's say, a customer has a model that they're currently using. Does that model take all of the existing customer inputs and continue to train itself? Or is it a matter of almost like a CI/CD pipeline, almost where that model gets, replaced with another model seamlessly? Like, tell me a little bit more about the, day one, a model gets rolled out, but what happens, 2 weeks from now, let's say?
Yeah, that's a great question. There is a CI/CD process. So there are academic areas of innovation where there are concepts like active learning and real-time learning, where these models can learn incrementally over time. And we do have some tools like that for if there are certain outputs where models just dramatically misbehave, then we can intervene and sort of course correct them. But for the most part, there is a complex machine learning model training pipeline where we start with the data. There's a process of feature engineering and understanding what are the important components of this data that these models should look at. And then there are algorithms and techniques that we use for certain model training. And then there is a process where we evaluate their performance. That's a sort of CI/CD part of it. But there is ongoing evaluation as well, because with machine learning, the world is no longer static, right? Like a website may be static or a file system may be more or less static. But with machine learning, you have this whole third dimension of users engaging with the model. And language is very fluid. And new employees join companies and they chat with the product. And so there is almost always this catch-up game that these models have to do. So that's a process that engineers, machine learning engineers at Moveworks, they evaluate based on logs. They look at model performance. And if models are drifting, if models are overfitting, or if models are peaking in performance, then we have to retrain them, replace them through our sort of machine learning CI/CD process. And that's something that we have gotten very good at doing now.
And who determines the success of the models? Is that based off of, say, user feedback and customer satisfaction, or how do you know a model is successful?
Yeah, that's a great question as well. And at the model level itself, things are very black and white, right? So there are metrics like precision and recall and F1 scores and area under the curve. So you have training data and then you have test data. And then you train the model on training data and then you evaluate on test data. We do have human annotators on staff as well, who apply expert judgment and labeling to the data. So we know that if a given model in isolation, what its performance is. But Moveworks as a product is incredibly complex. And there are, in even the simplest interaction, you could have dozens of models playing a part. So at the end of it, there is a user level metric, if you will. Was Moveworks able to understand what the user is saying? Was Moveworks able to take the right action per the expectation of the user? And did an issue get resolved completely or not? So that ultimately is the high mark on which we measure our performance and report back to our customers. So we start with the machine learning metric and layer on top these higher level user expectation metrics and resolution metrics.
Gotcha. And so it kind of, I was thinking actually too, probably one of the, at least for me, but maybe our listeners as well, one of the most frustrating things in the world for me is, you end up in those phone loops in the phone trees and those voice automated telephone systems, right?
Yeah.
You go to call into something and it'll say something and then it doesn't understand you. And oh gosh,
Yep.
I'm so not a fan of those, right? How do you handle I'll just use the term, the user frustration problem?
Yeah, I know exactly what you mean. And there are so many cases where you're on the phone and you are desperately hitting zero saying, let me just talk to a human being right away. Yes. I know. And a lot of this was in the era where this technology wasn't as mature. So one is the baseline of maturity with natural language understanding is improving overall. And then it also depends on the sort of design space where these bots and models are working in. And I can't comment on sort of, I've been in the loop with my internet provider or credit card companies where they say something like 1, confirm, and 2, deny. And if you say confirm, they are like, sorry, I didn't follow. You have to exactly say 1 or 2. And that is an artifact of how that conversation tree was handcrafted. And most chatbots, if you find on the market right now, they're designed that way. So you have a conversation designer and a bot builder. And they say, if the user says this, then do that. But if they say this, then do something else. And you can see like that's unsustainable. That can't function. So at Moveworks, 4 years ago, our first version prototype was built using a similar technology. And it fell flat in 20 minutes. Like the users walked away saying, this thing is dumb. It doesn't work. So we had to go back to the drawing board. And we said, okay, how do humans communicate? And when you and I are, let's say, texting or chatting, there is so much context. There is so much understanding that's built in. And we have tried to replicate that in our conversation engine. It's heavily patented. It looks at who you are, what you are saying, what you've said before, what you have said 3, 4, 10, 50 sessions ago to try and understand what is the next best action to take. So there is no designer inside Moveworks. And we also try to minimize frustration. Users, when they come to us, they are already frustrated. They have a problem. Their account is locked out. Application is crashing. They don't know where to go for some help. So they're in no mood for chit chat. They don't want to talk about weather or want to talk about restaurants or something else. They just want help and they want to get on with their daily jobs. So that's something that we have biased our design towards. And that's why all of our models are wired with high levels of precision. And if the model is not confident, we let the ticket go by to an IT agent. Because we know there's an agent who can pick up that ticket, and we help them by giving them additional context and metadata and categorization. So those tickets also don't bounce around unnecessarily, and they see acceleration between 30 to 40%.
Yeah, and it allows the IT teams to focus on the tickets that are the higher level work, if you will. That we're always trying to talk about, in our industry, trying to always remove friction and trying to get more done. No, that's perfect. And with that, we're kind of out of time for this week. Where can everyone find out more about you, about Moveworks, and everything else y'all have going these days?
Moveworks.com. So if you go to our website, you will find more information about the technology. We have a bunch of interesting case studies up with some of our customers. And I'm on Twitter as well, if you want to follow me and follow Moveworks. But it was great to chat more about this. Clearly, we are a bunch who are very, very passionate about IT tickets. And we really enjoy seeing the impact that Moveworks has. And thank you so much, Aaron, for having me.
Absolutely. Thank you so much for your time. And on behalf of Brian, who wasn't able to make it this week, thank you, everyone, for listening. And we'll talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.